Now this video won't make sense if you didn't just watch the one right before it where I went through the first pivot. So let me just pick up back there so to connect the two. So the previous video I went through the first pivot operation where I pivoted right here and got a 1 and then got zeros, and that made x2 be a basic variable. And so I had x2 as a basic variable, s1 as a basic variable, and p as a basic variable, and that meant x1 was now non-basic and s1 was now non-basic. And since x1 is non-basic, it was 0, s1 was non-basic, it was 0, and x2, s2, and p I found from the remaining values here. This tells me that x2 is 16, this tells me s2 is 20, this tells me p is 1280. But we noticed that we still had a negative 10 down here on the bottom row. So we're going to actually have to go through another pivot, because as long as we have a negative on this bottom row, we have not reached the optimal solution yet. So now, if you'll remember from the last video, the way you pivot, or the way you determine where you're going to pivot on, is you find the most negative indicator. Now, since there's only one negative indicator on the bottom row, then that means this column must be the pivot column, since it has the only negative indicator on the bottom row. And then, so what I have to do now is I have to take these two numbers, the 1/2 and the 1, and divide them into their corresponding constants over here to determine the pivot row. So I have the pivot column, but I got to determine the pivot row by dividing 1/2 into 16. Now 16 divided by 1/2, be careful, because I know you might be tempted to say 16 divided by 1/2 is 8, but actually 16 divided by 1/2 is 16 times 2, which is 32. And then if you take 20 and divide it by 1, you get 20. So if you look at these two quotients, the smaller quotient is 20, so the pivot row must be the second row here. And then since the pivot row and the pivot element intersect right here at this 1, then this would be where we're going to pivot. Now notice that I'm going to pivot on the x1 column, so that tells me x1 is now going to become a basic variable, and I'm also pivoting on the row that's associated with s2 as a basic variable, and so s2 is actually going to exit. Alright, so let's take a look at what happens here. I need to eliminate the 1. I need to use the 1 to eliminate all other values in the column. So I need to use this 1 to eliminate the 1/2. So the way to do that, if you remember working with matrices, we actually can just multiply this row by negative 1/2 and add it to this row to cancel the 1/2. So multiply everything in this row by negative 1/2, and you'll get negative 1/2 times 1 is negative 1/2 plus 1/2 is 0. Negative 1/2 times 0 plus 1 is just going to be 1. Negative 1/2 times negative 2 is actually 1, and 1 plus 1/2 is 3/2. Negative 1/2 times 1 plus 0 is negative 1/2. Negative 1/2 times 0 plus 0 is 0. And then negative 1/2 times 20 is negative 10, and negative 10 plus 16 is 6. Alright, now we also have to get rid of this negative 10, so we have to multiply this row by 10 and add it to row 3. So 10 row 2 plus row 3. Well, 10 times 1 is 10 plus negative 10 is 0. 10 times 0 plus 0 is 0. 10 times negative 2 is negative 20. Negative 20 plus 40 is 20. 10 times 1 is 10 plus 0 gives me 10. 10 times 0 plus 1 is 1. And then 10 times 20 is 200, and 200 plus 1280 is 1480. And so now I have my next tableau here, and notice now I have no negatives on the bottom row, and since I have no negatives on the bottom row, I now have my final simplex tableau, and I can find my solution. Now, to identify your solution, look for the first thing we need to do is look at the columns. Look for the columns that have the zeros and the 1. So I notice that x1, let me get this out of the way. So I notice that x1 is a column that has the zeros and ones, okay? And also, I notice that x2 is a column that has the zeros and the ones. And then I also notice that p has the zeros and ones. So these are your three basic variables. So x1 is basic, but let's look in x1's column and let's see where it is identified. See, it's actually only identified where the 1 is. So x1 is a basic variable. Let me tighten that up a little bit. So x1 is a basic variable, but it's associated with the second row. Now that means that the solution can be found for x1 in row 2, so I'm going to know that x1 is actually going to be 20. Now look in the x2 column. It's a basic variable, but notice the 1 is in the first row. So x2 is associated with the first row, so that means I'll find its value in the first row, which will be 6. And then p, it's identified with the last row, and I'll find its value in the last row, 1480. Now, since these three are the basic variables, then by elimination, S1 and S2 must be non-basic. And if S1 and S2 are non-basic, then those values are 0. And so we could just say, okay, they're just going to make all the terms disappear. And you can easily see now, if you read across here, you get 1x2 equals 6, 1x1 equals 20, and p equals 1480. So the optimal solution would be p equals 1480 at the point 26. So x1 is 20 and x2 equals 6. Now, if you wanted the s values, s1 is 0 and s2 is 0 because they're non-basic. Okay. Now, if you recall from the graph, the list of the feasible solutions, remember that when we solved this by graphing, we found that this was the corner point that gave the optimal solution, and the optimal solution was the value 14.8. Okay. Now, I'm going to work a couple more of these for you in another video, but if you want to do one for practice, right here, I've got one for you that you can practice on, and you can practice working this one. Well, this practice isn't actually for solving it. It just says give the initial system of equations and the initial simplex tableau. So that's all I did here. But it's a practice problem, because those are the first things you're going to have to do when you're solving a linear programming problem. By the simplex method, you're going to have to find the initial system of equations and write the initial simplex tableau. So I'm going to solve this one on the next video, so it's up to you whether or not you want to actually go through and work this one before you watch the next video or not. But I suspect you'll probably want to see another example done before you try to solve one on your own. That example that I just did, it had, like I said before, it had a lot of added stuff to it because I was explaining as I went through and worked the problem. But in the next video, it'll be a little bit quicker because I won't worry about all of those solutions that might have been had I stopped at a certain point.